Observer pattern is used whenever we have data, something like orders, parking spots, and then there are other classes which depend on that data. Whenever there is some change in this data, then updates need to be sent to these other classes. This is where observer pattern is used. In actual low-level design interviews, most of the time you will be using observer pattern along with strategy design pattern to send data to different strategy classes. Strategy classes are used to do the same thing but in different ways. Let's take the example of a food ordering app. You have basically different classes which return a list of restaurants when we search for some food item. We just saw that there can be multiple ways to do this. You can either return the list of restaurants based on their average rating. You can also return restaurants based on the number of 5 stars a particular food item has received. These search classes may need to maintain their own internal data structure because it is very inefficient to calculate or build such a list at runtime for each different request. They may have their own inbuilt lists and they just update it whenever any new order gets rated. That is, rate order method is called inside order manager, and update it sent to these classes and they update their internal data structure. And this is what the observer pattern is doing. It is gluing the class which is changing the data with the other classes which depend on that data. Another example can be of a parking lot. You can have multiple different parking strategies, and some of those parking strategies may have their own internal data structure, some sort of list or some sort of combination of map and set. Those internal data structures need to be updated when an spot has been booked using some other algorithm, so that the this algorithm can work correctly. So in these cases, we use observer pattern. Let's see how we do it. Coming to the implementation of observer design pattern, the idea is that there will be a subject and a list of observers, and subject will maintain a list of observers, and whenever data change happens, it will call its method notify all, and it will call the update method on all observers. Every observer class will have an update method in it. It will implement this interface. Each class will have this update method. Subject will be something like our orders manager class, which have the rate order method. Whenever rate order is called, it will call notify all, and this subject will maintain a list of all observers. Notify all will just iterate through all the observers and call observer.update, which will one by one send update to each observers. Pretty simple. Add observer method is given. We can add observers at runtime. We do not need to update any code in the subject class or class implementing subject interface whenever a new observer comes. Tomorrow, if a completely new observer comes, some analytics class or some sort of notification class which sends a notification to an restaurant whenever any order is rated 1, 2, or 3, like low, that okay, you need to improve your services or culinary experience. There we will just implement the algorithm. It will have the update method, and at runtime it will call the add observer with its object and get added to the subject and start receiving updates. Both the classes, the subject where data is getting changed is usually coupled with the observers, and we have the benefit of extension and readability. Let's see how observer design pattern is used in actual interview questions. Let's take the example of this design a food delivery system like Zomato, Swiggy, Uber. I have already opened the question. In a food delivery system, you can order food, you can also rate order, and there are two methods to display top restaurants based on their rating. There is slight difference between them. And then we have the method rate order. We were discussing just now the module which is rating the order is the subject, and the modules which are showing these lists will be our observer. Let's see how we have implemented. Our interface, we have named it rate order observer, and it has an update method, and our subject will have method to add observer and notify all observers. There is no method to remove observers because we do not need it. Let's see the observers first. These two classes, most rated restaurants and most rated restaurant by food, these two classes return the list of top restaurants. They are the observers and they maintain their internal list of restaurants in custom data structures. These two classes needs to be informed every time a new order is rated so that they can update their internal data structures. Our class orders manager will be our subject. It keeps list of all the observers in an array list, and it has the methods which are required. We have the add observer method to add the observer and notify all of the observers. Simply go through all the observers in the array list and call the update method on each of them because they all follow the same interface. And when the order is rated, simply call notify all to notify all observers. This is how a basic implementation is done in case of uh, uh, a food item, a food delivery system. Let's suppose tomorrow we have to add a new observer. We want to list top restaurants which have got the highest number of 5-star ratings. Again, here also we'll simply create a new class just below these classes, highest or most 5 rated restaurants, and that class we will add to this observers list using this method add observer. It will be notified through notify all method. Now that class will ignore all other ratings except the 5-star rating, so it depends on that class, and we do not have to make any single line code change in the orders manager. You see how it is good for extending code. Let's see a slightly different example where an observer pattern is used along with strategy design pattern. Take the case of a customer issue resolution system. In a customer support system, customers raise multiple issues and those issues are assigned to different agents who solve them. In the assign agent method, we have been applying 3 different strategies to assign agents. That can depend on the number of issues opened by the agent or how many issues of that type agent has already solved, basically different factors. The key thing to understand is there are 3 different algorithms for assigning agents. These 3 classes are the ones which have implemented all of these 3 strategies. These 3 classes also have their own data structure, and every time a new agent is assigned an issue, then all these 3 classes need to be informed about that so that they can update their internal data structures and assign agents to the issues correctly. We have used observer design pattern here. The name of the interface is issue observer. Then we have the issue subject which has attach and notify all method. These 3 classes will be our observer in this case because they have their custom list of all agents, and then they use that data to assign agents to different issues. For example, lowest issue open selector has all the agents in the map. Our issue subject will be class issue manager because it is taking care of all the issues, whether a issue is getting created, resolved or assigned. It has the attach and notify all methods. It stores all the 3 observer classes in this array list of issue observer. Whenever an issue is assigned to a new agent or any agent, it calls notify all to notify all the 3 algorithm classes. In this case, we have used observer pattern with strategy design pattern so that every different algorithm is informed about the data changes in the core data structure, that is an issue which is getting assigned. If you want to take away just one thing from here today, just remember that observer pattern is used when you want to have loose coupling between data and the views which depend on that data. This is all about observer design pattern. I have created a 7-day plan for preparing for your low-level design interviews. You can access it at codezym.com/roadmap. Generally, you have very less time to prepare for LLD interviews because the interviews are either in this week or upcoming week. So you won't have more than 7 to 10 days to prepare. I created this concise plan to answer all the questions which candidates have because there are a ton of content on the internet and on YouTube. People have questions like which topics to prepare first because time is of essence, and where to practice. It has got everything. It has got short videos, and there are daily practice questions which you can code and run on CodeZym editor and see that it passes all the test cases. It's the complete thing. Give it a try. codezym.com/roadmap. It will help you prepare for your LLD interviews pretty efficiently here. Best of luck for your interviews. Bye.